It's time to travel the world to see the top 15 most astonishing feats of human engineering. Let's start with number 15, the Millau Viaduct in France. This viaduct is a cable-stayed bridge that crosses the Tarn River Valley near Millau in southern France. It was designed by the French structural engineer Michel Virlegot and the British architect Norman Foster, with the aim of reducing traffic in the nearby town and to provide a direct route for the A75 motorway. The final design was made up of 11 slender piers, the tallest of which rises to over 1,100 feet or 343 meters, making it the tallest bridge in the world. Construction began in October 2001, with each pier built on site using climbing formwork, which is a technique that allows for continuous pouring of concrete. This ensured the strength and stability of the piers as they reached their full height. Once the piers were completed, the deck was added, which has been prefabricated in sections off-site. Each of the sections, weighing up to 2,300 tons, were transported to the site and lifted in the beauty of the bridge. Number 14, the Grand Canyon Skywalk, Arizona. A number of glass bridges have been built in sites of scenic interest around the world, but the one that's the most impressive in terms of both its design and its location is the Grand Canyon Skywalk in Arizona. Extending out over the edge of the world-famous Grand Canyon, it offers visitors an incredible view of one of the world's most important natural wonders. The glass bridge is horseshoe-shaped and reaches a distance of 70 feet or 21 meters out from the canyon's rim, allowing you to look over 4,000 feet down to the Colorado River below. Done in collaboration between a businessman from Las Vegas and the Hualapai tribe that gave permission to use the land, it first opened to the public in 2007. At first, the foundations were installed, which are a series of high-strength steel piles that were driven 46 feet into the bedrock, ensuring the structure would be anchored securely. The main structure is then made of steel and glass. Now, the steel frame was carefully installed. Testing was conducted throughout the construction process to ensure its stability, and the skywalk was, in the end, built to hold up to 71 million pounds, or 32 million kilograms, far more than the expected maximum load of visitors. Amazingly, it was all finished within just 4 years, and it's now become one of the most popular attractions in the region, giving a view of the canyon unlike anything else. Number 13, the Taj Mahal in India. The Taj Mahal in Agra, India, is one of the most recognizable and visually impressive structures on the planet. Commissioned by Emperor Shah Jahan in 1632 as a memorial for his wife, Mumtaz Mahal, it's now a UNESCO World Heritage Site and one of the most iconic symbols of India. Beginning with the selection of a site along the Yamuna River, which allowed for the easy transportation of materials, a 10,700 square foot or 1,000 square meter platform of compacted earth and stone was created to some meters, and it's a masterpiece of Mughal engineering. Constructed with a double-shell design, the inner dome maintains the structural integrity, while the outer dome was designed purely for aesthetics. Masons and engineers used advanced techniques for the time to ensure the dome's perfect symmetry and stability, including the use of large wooden scaffolding and pulleys to lift the heavy materials into place. Thought to have involved the efforts of tens of thousands of laborers, there is no doubt that it's one of the most impressive structures ever built anywhere in the world. Number 12, the Aqueduct of Segovia, Spain. The Aqueduct of Segovia, which can be seen in the historic city of Segovia in central Spain, is one of the most impressive examples of ancient Roman engineering that still remain. Built during the late 1st or early 2nd century during the reigns of Emperor Domitian, Nerva, or Trajan, its purpose was to transport water to the city from Rio Frio, which is a river around 10.5 miles away. The Romans were experts at building aqueducts, but the engineering kept the water flowing. Roman engineers used a number of techniques to create these gentle gradients, usually around 1%, to maintain a steady flow of water over long distances, without causing any turbulence or stagnation. The most iconic section of the aqueduct is the series of arches that pass through a plaza in the heart of Segovia. This section, which reaches a height of up to 60 feet or over 28 meters, is made up of 2 tiers of arches, the lower tier with 119 arches and the upper tier with 44. Each arch was built by assembling precisely cut granite blocks, held together by the force of gravity and the careful balancing of the stones. The keystone, which is the central stone at the top of each arch, played a critical role in distributing the weight and ensuring the stability of this structure. Number 11, the Panama Canal. Even today, with plenty of alternatives, as much as 80% of the volume of international trade is transported by ship, meaning that anything that can be done to reduce travel times will have a 3.5 meters wide, 1,000 feet or about 305 meters long, and 40 feet or 12 meters deep were vital and needed precision engineering and advanced construction to be possible. Excavation of the Galliard Cut, which is a 9-mile section through the Continental Divide, was one of the most challenging aspects of the entire project. It required the removal of over 2.7 billion cubic feet, or 76 million cubic meters of earth and rock, which was done with a combination of steam shovels, dynamite, and labor. Another huge part of the project was the construction of the massive dam, which created Gatun Lake, which became one of the largest artificial lakes in the world at the time. The dam, made from earth and rock, was crucial for the canal's water supply and for controlling the flow of water through the locks. It was finished within 10 years. The canal officially opened on August 15, 1914, and was an important moment in global trade and transportation. The completion of the Panama Canal reduced the sea voyage between the east and west coasts of the United States 1 meters. The idea for the bridge was put forward in the 1950s as weather conditions made the sea crossing unreliable. Initial planning began in the 1960s, and construction work finally began in 1988 after extensive feasibility studies and engineering research. One of the biggest challenges was the location of the bridge, as the Akashi Strait is a busy shipping route with strong tidal currents and frequent seismic activity. To be sure that the bridge could withstand these events, engineers used cutting-edge technology and materials within its design. It, for example, features 2 massive anchorages built from reinforced concrete which secure the bridge cables on either end and are buried deep into the bedrock. The main cables, which are essential to the structure of a suspension bridge, were formed from high-strength steel wires. Each cable is made up of over 36,000 strands of wire, making them incredibly tough and capable of supporting the weight of an entire bridge deck and the loads from traffic and wind. The cables were spun on-site using an aerial spinning method in dollars, and more than 2 million people were involved at various stages of the project. Now, transport between Awaji Island and the mainland is far more reliable, and it has transformed the local economies there. Number 9. The White Pass and Yukon Route Railroad in Canada. The White Pass and Yukon Route Railroad was built during the Klondike Gold Rush to connect the port of Skagway in Alaska to Whitehorse in Yukon, Canada. It's a narrow-gauge railroad that was completed in the year 1900 and covers a distance of around 110 miles, or 177 kilometers, through some of the most challenging terrain in the world. The idea for it came as a need to provide a more efficient route to the Klondike gold fields, as existing paths such as the Chilkoot and the White Pass trails were pretty difficult to use. Construction started in May 1898 and began in Skagway, which was a town that had sprung up almost overnight due to the gold rush. The first major challenge was the steep and rocky terrain of the ridge that was, at the time, the tallest of its type in the world. The railroad reached Lake Bennett in British Columbia in just over a year, and here, temporary terminus was established. The final push to Whitehorse continued, and with further tunnels and bridges, the railroad was completed in July of 1900, just 3 years after work began. And it went on to play a critical role in the development of the region, facilitating the transport of supplies, equipment, and people during and after the gold rush. Number 8. Boeing Everett Factory in Washington in the United States. Of all the giant structures that have been built around the world, the building that has, since being completed, held the world record of being the largest of all, in terms of its total volume, is the Boeing Everett Factory in Washington. With the main building having a volume of more than 472 million cubic feet, or over 13.3 million cubic meters, it's there that some of the world's most renowned aircraft, including the 747, cubic yards of soil being excavated to prepare the site. The primary structure of the factory was built using steel frames and large prefabricated panels, allowing for quick assembly, with the sheer size of the building posing unique engineering challenges, including the need for a toughened foundation because of the weight of the building and equipment, and a roof structure capable of spanning huge distances without interior support columns. Throughout its history, the Everett factory has undergone several expansions and upgrades. In the late 1980s and early 90s, it was expanded to accommodate the production of the Boeing 777, a long-range, wide-body twin-engine jet. The most recent major addition to the Everett factory was for the production of the Boeing 787 Dreamliner. This aircraft, made largely of composite materials, required new manufacturing techniques. Boeing invested in state-of-the-art assembly technology, including automated fiber placement machines and robotic drilling systems. This all streamlined the production process. Moving on to number 7, the Channel 20th. Once technology available made it realistic. The modern project began with a treaty between the UK and France in 1986, and construction officially commenced in 1988. The tunnel itself is made up of 3 parallel tubes, 2 for rail traffic and a central service tunnel for maintenance and emergency use. The twin rail tunnels have a diameter of 25 feet or about 7.6 meters, and all 3 were constructed using tunnel boring machines, which are massive mechanical excavators. The construction began at the same time from both the British and French sides. The tunnel borers were deployed to dig through the earth, with crews working around the clock. These machines not only excavated the soil but also installed precast concrete lining segments to support the tunnel walls. One of the trickiest aspects of the project was therefore making sure there was a precise alignment of the tunnels from both sides. Advanced surveying techniques, including laser guidance systems and satellite positioning, were used to be certain that the 2 sides would meet in the middle. The Pyramids of Giza, Egypt. Undoubtedly, the most famous and recognizable ancient monuments anywhere on the planet, the Pyramids of Giza were built during the 4th dynasty of the Old Kingdom, around 4,500 years ago. The 3 pyramids were constructed for the pharaohs Khufu, Khafre, and Menkaure, with the biggest and most famous, the Great Pyramid of Khufu, being the largest pyramid ever built. These monumental structures required planning, vast resources, and advanced knowledge of math and engineering to make it a reality. The site was prepared by leveling the ground, and the ancient Egyptians used a grid system to ensure the base of the pyramid was perfectly square. This involved laying out a series of right angles using ropes and stakes and using simple tools like the plumb bob and the level to achieve the necessary precision. The core of the pyramids was made from large blocks of locally quarried limestone, while the outer casing was made from finer white Tura limestone, which gave the pyramids their smooth, gleaming appearance. The stones were known for certain. Tens of thousands of workers were involved, and contrary to earlier beliefs, this wasn't forced labor. Instead, the workforce was made up of skilled tradesmen, craftsmen, and a large number of temporary workers, possibly recruited from the local population during the agricultural off-season. They were well-fed and well-treated, and all lived in nearby temporary villages. Number 5. Ranakot Fort in Pakistan. Ranakot Fort, which is in the Sindh province of Pakistan, is one of the world's largest forts, often referred to as the Great Wall of Sindh. With a circumference of around 20 miles, there's surprisingly little we know for certain about the structure. The fort's construction, history, and purpose remain unknown, but it's generally believed to have been built during the reign of the Talpur dynasty in the early 19th century. The main purpose of the fort was likely defensive, as its location along a range provided natural strategic advantages, with the fort's walls following the contours of the hills and cliffs, making it difficult for attacking. Elements of the design is the series of semicircular bastions and watchtowers, which were placed along the walls to provide vantage points. The bastions are equipped with gun slits, enabling defenders to fire upon attackers. And the labor force required to build the fort would have been enormous, probably in the tens of thousands, involving skilled masons, laborers, and possibly artisans from the surrounding area. And it's also believed to have taken as long as a decade to complete, thanks to the complexity of the terrain and the huge stone blocks that needed to be lifted into place. Number 4. The Colosseum in Rome. The Colosseum, officially known as the Flavian Amphitheater, is probably the most iconic structure of ancient Rome. Constructed under the emperors Vespasian, Titus, and Domitian, it was completed in AD 80 and became the entertainment center of the city, hosting gladiatorial contests, sea battles, and public spectacles, and plenty more. Work on it began 10 years earlier under Emperor Vespasian of the Flavian the site using a sophisticated network of roads and infrastructure, and the stones were held together without mortar, using iron clamps that were later removed, which led to the visible pockmarks on the walls you can still see today. The Colosseum's interior could accommodate between 50 to 80,000 people, who were seated according to their social status. The seating was arranged in a tiered manner, supported by a series of barrel and groin vaults, which provided structural strength but also helped with crowd movement. Beneath the arena's floor lay the hypogeum, which is a complex underground network of tunnels and chambers where the gladiators and animals were held before contests. This area also contained advanced machinery and trapdoors that allowed for dramatic and surprising entrances. Number 3. The Golden Gate Bridge in San Francisco. The Golden Gate Bridge is a symbol of San Francisco, and it's one of the most recognizable structures in the world. Covering a distance of 1.7 miles or 2.7 kilometers across the Golden Bridge design that incorporated Art Deco elements. Building the Golden Gate Bridge involved overcoming several huge challenges. The strait's turbulent waters, strong tides, and frequent fog made it really tricky, and the first major task was completing the 2 massive towers. Each tower stands about 746 feet or 227 meters above the water, and it was built using prefabricated steel sections. Once the towers were in place, the next phase was spinning the main cables. These cables are made up of over 27,000 individual wires, totaling 80,000 miles or 128,000 kilometers of wire. This process involves spinning the wires back and forth across the strait, using a technique called cable spinning, which had previously been used but never on such a scale. The roadway deck made of prefabricated steel sections was then installed. These sections were hoisted into place and secured to the suspension cables, completing the main structure. The final stage involved painting the bridge, both for aesthetic reasons and to protect the steel from corrosion. The tallest man-made structure on the planet, the Burj Khalifa in Dubai, reaches an incredible height of 2,717 feet, or 828 meters. The initial concept of this skyscraper was part of a larger initiative to diversify Dubai's economy from its oil-based roots towards tourism and luxury. The building's foundations consist of large reinforced concrete mat, 12 feet or 3.7 meters thick, supported by board reinforced concrete piles, each 5 feet in diameter and up to 160 feet deep. The mat and piles were designed to distribute the building's enormous weight, which reaches about 500,000 tons, across the relatively weak soil found in the Dubai region. The structural system of the Burj Khalifa is a reinforced concrete core with a hexagonal footprint surrounded by a series of wings arranged in a Y shape. This design, known as the buttressed core, was a revolutionary idea providing stability against lateral forces exerted by wind and seismic, reduce heat absorption and reduce maintenance requirements. The spire of the building, which is impressive in its own right, was constructed using a combination of structural steel and aluminum. It housed communication equipment and was installed in stages, with workers assembling sections on the ground before hoisting them up. Throughout its construction, the Burj Khalifa relied on the expertise of over 12,000 workers and engineers from around the world. After 6 years of construction, it officially opened on January 4, 2010, and since then, no other building has yet come close to taking its crown. Number 1. The Great Wall of China. The Great Wall of China is an almost unbelievable structure that stretches over 13,000 miles, or almost 21,000 kilometers across northern China. Its construction was done in stages across several dynasties, beginning as early as 2,700 years ago, and it was primarily built to protect Chinese states and empires from various groups from the north. The earliest sections were built by various states during the 21 BC. Recognizing the need for a defense, he ordered the connection and expansion of the existing walls, which the construction method during the Qing dynasty involved the use of rammed earth, which is a technique where the earth was compacted between wooden frames to form solid, sturdy walls. The construction process here required a massive labor force, which included soldiers, peasants, and prisoners. It's estimated that hundreds of thousands of people were involved in the building of the wall during the Qin dynasty alone. The Han emperors employed more advanced construction techniques, incorporating bricks and stones in some sections to improve durability, and watchtowers and beacon towers were added to enhance communication and military readiness. The most well-known sections of the Great Wall, and those that are seen today, were built during the Ming dynasty between 1368 and 1644. After the Ming rulers regained control from the Mongols, they undertook an ambitious project to rebuild and expand the wall using stronger materials like bricks and granite. These walls were thicker and higher, with a complex network of watchtowers, garrison stations, and fortresses. The construction of the Ming Wall was meticulously planned and executed. Workers transported materials using a variety of methods, including human chains, animals, and machinery. While never exactly being a single continuous wall, but a series of walls and fortifications built by different dynasties over centuries, the Great Wall has been the most continuously updated structure in human history, and one that was vital in helping to strengthen and forge a nation. Thanks for watching, everyone. I'll see you next time.